Hi there, my name's Bruce Rain from Brankus Creations, and in this video we'll be taking this laundry sink and turning it into an ultrasonic cleaner with nothing but sheer willpower. And this big pile of ultrasonic cleaner parts. Now you might be asking why? Why turn a laundry sink into an ultrasonic cleaner? Well, it's not as wacky as it might sound. This big 42-litre tub will allow cleaning of some pretty large items, and the convenience of a tap or faucet and drainage will make filling and emptying the tank super easy. Things like a barbecue grill, pots and pans, paintbrushes, tools, car parts, and it may surprise you to hear that you can actually use an ultrasonic cleaner for cleaning clothes as well. They can dislodge dirt and grime from the fabric. Unfortunately, there's nowhere for that grime to go, so you still need to rinse the fabric afterwards. But I'm looking forward to seeing how effective it is as a washing machine. At this stage, my wife still doesn't know about this little upgrade, but seriously, how can she not love it? This is actually the second ultrasonic cleaner I've made, and you can watch the shenanigans of the first build with the link here. Over the course of the last couple of years, I've learned a great deal about how to not only build an ultrasonic cleaner, but how to build it so that it's effective and reliable. If you're a little fuzzy about what an ultrasonic cleaner is or how it works, I'd highly recommend you check out the beginning of that video. I cover everything you would ever want to know about ultrasonic cleaners, and quite a bit you probably don't want to know as well. So just a quick recap. An ultrasonic cleaner uses emitters or transducers to emit ultrasonic sound, and those transducers need a driver to make them work, a bit like a speaker and an amplifier. So to turn this tub into an ultrasonic cleaner, the first thing we need to do is attach some ultrasonic transducers to the base. I had a lot of trouble with this stage in my first ultrasonic build, but thankfully I've got all of the problems ironed out. The transducers look like this, and they also have a little bolt like this. We need to weld or solder this little bolt to the underside of the tank and then apply some high-strength epoxy to the flat part of the transducer, then screw it down tight onto the bolt. The bolt holds the transducer firmly in place, and the glue helps to stop it from coming unscrewed, and it also serves as a conduit for the ultrasonic sound waves to pass through the tub. This is why we use a hard epoxy rather than a silicone or silastic adhesive, as they have too much flex and don't transmit the sound waves as well. I have a small challenge with this tub, as it has a drainage hole right in the middle, which prevents me from placing a transducer there. So I need to try and position the transducers so they are reasonably equally spaced around the area I can use. This is a 60-watt transducer. The general rule of thumb is that you need about 25 watts per litre of liquid in the tub, or 100 watts per gallon. So this will work with about 2.5 litres. This is a 42-litre tank, so I'll certainly need more than one. It's actually pretty impractical to fill these tubs right to the top, so it's more likely to be holding around 30 litres when full. That's 750 watts or 12 transducers. I should also mention that if you run a transducer with a dry tank or a tank with a lot less liquid than the transducers were designed for, they can overheat and die. So it's important the tank is filled up before they get switched on. I have 12 transducers here. A 120-watt ultrasonic driver can power 2 of these 60-watt transducers at once. So I'll need 6 drivers, which is good, because that's how many I have. I've opted for 40 kHz transducers. It's generally accepted that a higher frequency should be used for more delicate items. If cleaning more robust things like engine parts, a lower frequency such as 28 kHz could be used. The lower frequency produces larger bubbles and more powerful cavitation. I could probably have gone with 28 kHz for the sorts of things I plan to clean in this, but I decided 40 kHz would give me better flexibility. I bought these ultrasonic cleaner parts from AliExpress, and you'll find links in the description. Just keep in mind that I purchased drivers that are powered by 220 volt AC mains. Make sure that when you buy your drivers that you buy one suited to the mains power voltage in your neck of the woods. In my previous videos, I've had lots of people say that adding multiple ultrasonic drivers results in them cancelling each other out and being ineffective. I have done extensive testing of this theory and it is incorrect. As we add more drivers and transducers, we will increase the cleaning power. End of story. I've marked out the location where I'm going to attach my transducers. The first step will be to silver solder or braze these little bolts into position. For this, I need a blowtorch like this, some silver solder, and some silver soldering flux. The silver solder can be a bit pricey because of the silver content, but thankfully we won't be needing much. When I did this before, the heat actually made the tank swell, and that made it really hard to keep this bolt still. It just kept sliding around the place. So as an experiment this time, I have a bicycle chain, and I'm going to just drape this over top, and hopefully the weight from that chain will be enough to keep that bolt from moving until I get it soldered into place. So we are down to the last 2 bolts. Now I decided that rather than try and demonstrate this with the first couple where I made a complete mess of it, I would wait until I'd had a chance to practice a little bit, and now I'll demonstrate the process that I'm using. So to start off with, I'm using some sandpaper to sand off the area that I'm going to solder to. This makes sure that it gets any oxidization in the metal off and will make the solder adhere much, much better. Now I'm going to put on a pretty liberal amount of flux onto here. It's very windy here today, unfortunately. That's the joys of Sydney at the moment. And that is wreaking havoc with my blowtorch. It keeps getting blown out. I'll just get the flux on there, and then we'll get our little bolt. We'll drop him into place. There we go. And got my chain. The chain idea has worked out quite well. It's sometimes a bit fiddly, but on the whole it does seem to be doing a good job of holding that thing in place. Better off going that way. I think I'm better off going that way. Yeah, let's try that. Okay. Let's see how many times this goes out while I'm trying to do this. Now this needs to get really, really hot. I mean, I know that shouldn't be surprising to anyone, but that solder isn't really going to flow and stick well until this is like really blazingly hot. So I've got to wait until that bolt is pretty much red hot. You try and put the solder on too soon, it'll probably melt onto there, but it'll just stay as like a little solder sausage. It won't actually flow around into the joints and properly adhere the 2 bits of metal together. Fumes coming off the flux are pretty toxic and awful, so probably should be wearing a mask. I'm not wearing one because it makes it very hard for me to talk while I'm doing it. When the solder is flowing well, it goes really shiny and just, you know, melts all into the joints, and that's what we want. That looks good to me. Just let that cool a bit before I take the chain off. And one left to do. And we are done. That is 12 little bolts soldered onto the tank. The next step will be to wash all of that flux off, and then I will use some sandpaper to make it all look pretty, get rid of all the dark spots, and that should do it for now. I had a bit of trouble getting the dried flux off. I've since read that hot water is the best thing for brazing flux removal. I used cold water, a few different solvents, wire brush, sandpaper, and a lot of elbow grease, and eventually got it off. Not a big task if I was only doing a couple, but for 12 of them, it took me forever. It's no oil painting, but it's clean enough to proceed. The metal of this tub is thinner than the tank of my last ultrasonic cleaner build, and as a result, the warping caused by the heat was more pronounced. Now that the tank is a bit lumpy, the glue will play an important role of filling any gaps between the surface of the tank and the surface of the transducers. I used a high-strength epoxy adhesive for gluing the transducers. I mixed up a big batch, applied a liberal amount to the surface of the transducers, and then screwed them tight with an Allen key. It's important to screw them tight, but not too tight. If you over-tighten, you run the risk of pulling too hard on the little bolt and distorting the tank metal, which is exactly what I did. You need to use enough adhesive so that it oozes out all the way around the edge when tightened. You don't want any air gaps between the transducer and the tank. Be careful not to get any adhesive into the bolt hole, as this can create a hydraulic lock and you won't be able to tighten the transducer all the way down. The uneven surface of my tank left a couple of small gaps that I then filled with some extra adhesive. Here is the end result after the epoxy has cured. There are no gaps around the transducer edges, so we're looking pretty good. So that's it for attaching the transducers. Time to have a look at the drivers. I have 3 different types of ultrasonic driver here, all bought from different sellers on AliExpress. They all look a bit different, but they all basically do the same thing. They all have 2 pins for the AC input, and 2 pins for the DC output to the transducers. This is the driver I'm using for this build, and they don't have any labels on the AC input to indicate which is live and which is neutral, so it probably doesn't matter which way around they go. My friend Steve from the Mac84 YouTube channel has an ultrasonic cleaner which uses these exact drivers, and his has been wired with the live on the top pin and neutral on the bottom pin, so I'll do the same. The output to the transducers is labelled with positive and negative. We'll discuss that a little later. One of the issues I experienced with my first ultrasonic build was failing components. My design didn't really allow for easy access for repair and replacement of those components. And while I'm quite confident I won't be experiencing those same issues with this cleaner, I still want to design it with easy access to the various components in the event of a failure. One of the great things about this laundry sink is the huge base. I have lots of room for making everything accessible. To that end, I designed and 3D printed this case for housing each of the ultrasonic drivers. Each case holds one ultrasonic driver and has its own 50mm 12V DC fan for cooling. This dovetail joint allows for easy installation and removal from this 3D printed bracket. None of this is really necessary and is more of a convenience. You could just get some wood and mount it to the base of the sink and then mount the drivers on those. But I decided I wanted an easily accessible and modular design. And here is a completed driver module. You can see I've used this locking connector so that I can easily connect and disconnect all the cables of each module. Now we need to wire things together, so here's my schematic. I have a mains master switch here. When this is powered on, the fans will start up and the cleaner is ready for use. I'm using 12V fans because they're cheap, but this means I have to use a 12V power supply. I had a few spare power supplies, so I'm using this 4.2 amp unit. It's overkill because each fan only uses 190 milliamps. So all 6 fans use less than 1.2 amps.
but it's what I had. Any 12 volt DC power supply with a minimum of 1.2 amps would be fine with these fans. Over here I have a countdown timer switch. It's just a rotary mechanical switch and is very basic but perfectly functional. To switch it on, just turn the dial to the duration you want, then it counts down to 0 and switches off. This mechanism might seem a little low tech, especially compared to the digital timer on my other cleaner, but it is very practical and perfectly functional. I bought this timer from AliExpress and it has a maximum runtime of 15 minutes. With a DIY cleaner like this, I generally recommend against running it for more than 15 minutes at a time, so this timer enforces that. If you want to run it for longer, just do it in multiple cleans with a break in between for things to cool down a bit. I have also put in this shut-off override switch. If I start a cleaning cycle, then I accidentally drop my glasses into the cleaner, I can stop the cleaning while I fetch my glasses, then switch it on again when my hands are clear, without having to fiddle with the timer switch. As I mentioned earlier, each driver powers 2 transducers and they are wired in parallel. The transducers have 2 tabs, one in the middle of the piezoelectric discs and another above or below them. The one in the middle should be wired to the positive output of the driver, the one above or below should be wired to negative. I have been told that you can actually reverse the polarity and they will still work, but you must reverse the polarity of all of them. If half are wired correctly and the other half are wired backwards, they will cancel each other out. So let's start wiring up these transducers. The recommendation is to use a low soldering iron temp to avoid damaging the transducer, but I'm actually going to do the exact opposite. I have a great big fat beveled edge soldering iron tip to help with heat transfer, and I'm going to crank up the temp to 400 degrees Celsius. My goal is to get in and out really quickly so that there's no prolonged exposure to the high heat. The first thing I'll do is get a nice big lump of solder on the tab, then let it cool. Next, I'll get a big lump of solder on the wire. Finally, I'll quickly melt the wire to the tab and we're done. I have always tended towards high heat and fast soldering, but this method may not suit others. If in doubt, drop the temp of your iron. I'd also recommend using leaded solder because it has a lower melting point than lead-free solder. When I need to solder 2 wires to the tab, I'm crimping them together with this ferrule, then soldering that to the tab. I'm wiring the transducer pairs in a pattern like this.
I added these little connectors to the transducer wires so that I can easily disconnect them for removal of the tub. And this has been invaluable during the building and testing phase.
I mentioned before how important it is to fill an ultrasonic tank with the appropriate amount of liquid based on the amount of cleaning power, but I don't want to have to fill this tank to the top every time I use it. If I'm cleaning something small, I don't want to waste all that water. So I'm building this cleaner with individual switches for each driver. So I can run the cleaner with just 1 driver, or 2, 3, 4, 5, or all 6. And I can also configure any combination of the drivers. I need to distribute AC power to each of the drivers and distribute DC power to each of the fans, so I bought 4 of these distribution bars, 2 for AC and 2 for DC. I then designed and 3D printed a housing for the bars and the 12-volt transformer. Speaking of 3D printing, did you know that channel sponsor PCB Way do 3D printing? They don't just make PCBs, their state-of-the-art factory also provides CNC machining, flex PCBs, injection moulding, stenciling and PCB assembly. They are one of the most experienced PCB manufacturers in China, and as a regular PCB Way customer, I can vouch for their low prices and excellent service. If you like building things, check out the great value and fast turnaround of PCB Way. I bought these great big chunky illuminated switches that look like they came straight off the control panel of Doctor Who's TARDIS. White ones for the power switch and override, and green ones for the individual drivers. They are also water resistant, so if a bit of water splashes out of the tub onto the control panel, we should avoid any nastiness. And the last item I bought for the control panel is this, an AC current monitor. This will show me exactly how much power the cleaner is using. I know how much the cleaner should use, so if the control panel shows too little or too much current, I know something's wrong. Once again, I designed and 3D printed a case for the control panel, and the finished product looks like this. And the wiring inside looks like this. There are probably more efficient ways of wiring the cleaner, but this is how I did it. The mains power comes from this plug on the side. This plug has a built-in switch, but when the tub is installed, that switch won't be very accessible, so I've set up another main switch on the front panel. So the AC goes up to the control panel switch, and from there it splits in two. One wire goes back down to the DC power supply for the fans, and also goes across to the override switch, then to the timer switch, then it goes back down to the AC distribution bars. From here they split into 6 separate wires that go up to the control panel and to each of the 6 driver switches. Then they come back out and go to each of the driver boxes. Remember, this is AC mains power, so don't mess with it if you don't know what you're doing. It can kill you. So this is it. It's not installed in the laundry yet, but it is fully functional, and I think it's time for a test. I've filled the tub with about 30 litres of water. When I power it on, the AC monitor lights up and the 6 fans start spinning. They are using about 12 watts of power. I have all 6 transducers in the on position, so once I turn the timer switch, it should start cleaning. And away she goes. Let's test out the shut-off override switch. Great, that works. So the first thing I need to do is the foil test. I'll place a sheet of aluminium foil into the water and start the cleaner. If everything is working correctly, we should end up with some pitting and some small holes in the foil. This is an indication that the cavitation process is happening and the cleaner is actually ultrasonically cleaning. I'm going to run the cleaner for 3 minutes, then we'll see what it looks like. Well, I don't think there's much doubt that it's working. I expected some pitting, but we have some sizable holes as well. And that's it for the Laundry Sink Ultrasonic Cleaner video. Look out for my next video where we put the new cleaner to the test with a variety of different cleaning tasks. Please consider giving this video a thumbs up, and if you like the content, please subscribe to the channel. Thanks for watching.